Good evening, everyone. My name is Suryaansh, and if you're able to see my screen, just give me a yes on the chat so that I know that you're able to hear me. All those who have just joined, just give me a yes on the chat so that I know that you're able to see my screen and are able to hear me. Perfect. Thank you so much, Aniket. So good evening, everyone. Thank you so much for joining. My name is Suryaansh, and today we will be discussing some tricks, some shortcuts on functions, and the questions that have come in the CAT exam in the past related to the functions topic. So yeah, simple, straightforward agenda, and looking forward to discussing that with you over the next 55 minutes. Let's just wait for everybody to join in. All those who just joined, just give me a yes on the chat. Fast, so waiting for others as well. So good evening. Some of you have joined now. So, a very warm welcome. Thank you so much for sparing your time on a Saturday evening. My name is Suryaansh, and those of you who just joined, just give me a yes on the chat so that I know that you're all set and up for the session today. All those who just joined, just give me the chat. In the functions topic, providing you certain tricks, certain shortcuts or solutions on how best to proceed with those questions and solve them in the least amount of time. So yeah, without wasting any further time, let's begin with the session. Okay, so this is the first question. This was a exam question in 2008. Simple question, not a very difficult question. So let fx be a function satisfying fx into fy is equal to f of xy for all real x comma y. If f2 is equal to 4, then what is the value of f of half? Okay, so I think it's not a very difficult question. No volunteers? F of x into f of y is basically given as f of xy for all real x and y. If f2 is given as 4, then what is the value of f of half? I'm sorry, Nitin, for the technical glitches and for the lag. I will try to. Basically, what's given here is f of x into f of y is basically f of xy, and f2 is equal to 4. There are two methods in which we can solve the question. Both the methods would be fine. One method is sure shot, that will definitely give you a right answer. Another method is a kind of a shortcut that will take less time, but there might be a certain, I would say, certain risk because because one of the options is also cannot be determined. All right. So what's given here is f of 2 is given as 1 but 4. All right, and f of x into f of y is basically xy. So basically f of x into f of y is given as f of x y. Let's put x and y is equal to x. All right, let's put that. Then f of x into f of x, that would be equal to f of x square. right? That means f of x whole square is equal to f of x square. From this, we can actually, eh, like the best example that can come to your mind, that should come to your mind from this thing would be that f of x is basically equal to x square. And f2 is equal to 4, that is also matching. If f of x is equal to x square, then f of 2 would be equal to 2 square, which is 4, which is also given. Then f of half should be basically just be equal to 1 by 2 whole square, which is equal to 1 by 4, which is equal to 1 by 4, right? The answer should be 1 by 4. Simple question, right? You just have to substitute y is equal to x, and you can get this answer. F of x whole square is equal to f of x square. That means f of x has to be x square, right? And this is also, this point is getting proved because f of 2 is also given as 4. So it's straight away it's x square. All right. So this is one method. This is also an easy method. It should not take you more than 15 to 20 seconds to solve this question. You just have to come to the conclusion that the f of x is basically x square. Once you do that, you'll be able to find f of half, which is 1 by 4. To f of y is given as f of xy, right? F of x, this is the second method, f of x into f of xy, xy is equal to given as f of xy. Now what we know is f of 2 is equal to 4. So let's put x is equal to 2 and y is equal to 1. That's the first substitution. And then f of 2 into f of 1 would be equal to f of x into y, which is 2 into 1. 2 into 1. That means f of 2 is given as 4. 4 into f of 1 is basically f of 2, which is again 4. From this, we can find out that f of 1 comes out to be equal to 1. From this, we can find out that f of 1 comes out to be equal to 1. So, once we know this, now we have to just, so we know f of 1 is equal to 1. So now the second case we would put is, let's put x is equal to 2 and y is equal to, let's put that. If you put that, then f of 2 into f of half should be equal to f of 2 into half. F of 2 is given as 4. F of half we need to find out. That's what we have to find out. And that is equal to f of 2 into 1 by 2, which is f of 1. F of 1 is this 1. So 4 into f of half is equal to 1. That means f of half comes out to be equal to 1 by 4, which is again option. So two methods I have told you. One would be to come to the conclusion that f of x is basically x square because no other value is satisfying. And the second thing is, second way is to substitute the values of x and y. So first you substitute x is equal to 2 and y equal to 1. Find out the value of f of 1, which comes out to be 1. Then substitute x is equal to 2 and y is equal to half because f of half you have to find out. And then that gives f of 2 into f of half is basically f of 1, 2 into half. F of 1 is 1, so f of half comes out to be 1 by 4. Alright, so that's another way where you can straight away find out the answer as 1 by 4. Alright, simple question, not a very difficult question. Both the methods should not take you more than, I think, 15 to 20 seconds for the first method, and I think 30 to 45 seconds for the second method. I don't think it should take you more than this. Alright, any questions, anybody? No questions? I think it's a simple one, not a very difficult one. So yeah, I think we should move ahead then. Okay, second question. Again, this was a CAT question in 1994, long back, 25 years back. So let's try this. F of x is given as 2x plus 3, and g of x is given as x minus 3 by 2. Then f of gx. F of gx. That's what you have to find out. F of x is 2x plus 3, and gx is x minus 3 by 2. So basically, just substituting f of, just in place of x, substitute this. That's it. So 2 into x minus 3 by 2 plus 3. 2 and 2 would be cancelled. We will be left with x minus 3 plus 3, which is equal to x. So f of gx is basically coming out as x. Now in the options we are given f of, the answer, one option is 1, which is wrong. G of fx, we don't know. G of fx divided by 16x. Sorry, this is also not true because we are getting 1 x here. This is also wrong. So this is also incorrect. And finally, third last option is 1 by x, which is also wrong. We are getting x. So we have to just try whether g of x also comes out to be x. So then we try out for g of fx. We try for g of fx. All right. Yeah. So if we try for g of fx, then instead, yeah, x minus 3 by 2 is g of x. So then instead of x here, substitute 2x plus 3. That would be 2x plus 3 minus 3 by 2. Instead of x, we are substituting fx, which is 2x plus 3. That's it. So this comes out with 3 and 3 would get cancelled. We would again be left with x. So this is also coming as x. This is also coming of x. That means f of gx will be equal to g of x. The answer is option B. All right. The answer is option B. It's a very simple question. Should not take you more than 30 seconds to solve this. Uh, yeah, and came in 1994. So I think you should get this answer correct. It's not a very difficult one. Just first find out the value of f of gx. Instead of x, we just substitute the value of gx, which is x minus 3 by 2. This is compound or composite function, right? So then we found out that f of gx comes out to be equal to x. So this was not given in any of the options x. So we'll then, one of the options that might be true would be g of fx. So we search for g of fx. So g, instead of x, just put the value of fx, which is 2x plus 3. Again, that comes out to be equal to x. That shows f of gx is equal to g of fx. So LHS is equal to RHS. So answer is option B. All right. Any questions, anybody? Okay. Any questions? No questions. So go ahead if there are no questions. Okay. So this is third question. This came in 2000. This is slightly complicated with respect to the first two questions that we have discussed so far. So what's given here is which of the following equations will best fit for the given data. We are given the values of x and y, and we have to find out the relationship between y and x. So for x equal to 1, y is coming as 4. For x equal to 2, y is coming as 8. For x equal to 3, y is equal to 14, 4, 22, 5, 32, 6, 44. Okay. So now first is a line, simple linear function. Y is equal to ax plus b. Alright. Okay. So what's given here is first when x increases by 1 from 1 to 2, or y increases by 4. Alright. Then if y x increases by 1 again from 2 to 3, y increases by 6. So here the difference is 4, here the difference is 6, here the difference is 8, here it is 10, here it is 12. 4, 6, 8, 10, 12. So it's not a linear variation of y with respect to a linear variation in x. If we increase x by 1, then it doesn't mean that y would also increase by a fixed amount. It's first increasing by 4, then it increasing by 6, then 8 and 10, and then so on. So it's not a linear variation. So obviously this option is wrong. Basically, the relationship shows the variation of y with respect to x. So if x is increasing, then y is not increasing uniformly. The increase is also increasing basically. First it was increase was 4, then it was 6, then 8. So it's an AP, increasing AP. All right. So it's not a linear variation. So the next option that comes to your mind would be a quadratic or a yeah um, quadratic relationship. That means yeah, option B, which is y is equal to a plus bx plus cx square. All right, a plus bx plus cx square. Now it's an increasing AP. All right, with increase in x, the y is also increasing, and the increase is also increasing. So basically, the first relationship that shows, and this is this is a linear AP. That means the increase is linearly increasing. All right, the increase is linearly increasing. So that means the option that is true would be quadratic equation. And the equation that comes out would be just, if you actually observe this, you would find that for x equal to 1, y is equal to 4. For x equal to 2, y is equal to 8. So the relationship that comes out would be x square plus x plus 2. You can either solve this for 3 values and find out the values of a, b, and c. For x equal to 1, 2, 3, y equal to 4, 8, 14. Just substitute the values of x as 1, 2, 3 and y as 4, 8, 14 for the respectively, and solve. There will be, you would get 3 equations and 3 variables. You will get that a, b, and c comes out to be 1, 1, and 2. So this is a relationship. You can actually check this for putting any value, substituting any value. Like for x equal to 1, y would be 1 square plus 1 plus 2, which is 4. This is matching. For x equal to 2, y would be 2 square plus 2 plus 2, which is 8. This is also matching. For x equal to 3, y would be 3 square plus 3 plus 2, which is 14. This is also matching. Alright, and so on. So this would match for all the things. So this is the equation, which is of the form of a quadratic equation between y and x. The answer is option B. Okay. So answer is option B, which is a quadratic relationship. So the equation that would best fit would be okay. So Sanchita, the third option, the eliminate would be y is equal to e raised to power ax plus b. Okay. Now the y equal to e raised to power x, the graph is something like this. The graph is something like this. Okay. Y is equal to e raised to power ax. The graph is something like that. Oh, okay, my bad. This is a log function. The graph for e raised to power x would be something like this. My bad. This is y. This is x. Y is equal to e raised to x. Right. Now, you now this is the reason I eliminated option 3 would be because this increase is linear. So first the difference is 4, then it is 6, then it is 8, then it is 10, then it is 12. In case of a exponential function, which is option 3, this increase won't be linear. This increase would also be exponential, because differentiation derivative of an exponential function remains the same. It's also an exponential function. So this increase would also be an exponential increase, but it's not. Here it is a linear increase, 4, 6, 8, 10, 12. It's an increasing AP, and the common difference is 2. So that's why it's a linear AP. So increase is linear, so that would be the next order with respect to y and x. That's why it would be a quadratic equation. This is a log function. This is the equation for y is equal to e raised to y. This is the graph. Okay, so that's why I eliminated option C. Y is equal to e raised to by ax plus b won't be true, because it's an because the increase is linear. Increase is not exponential, like 1, 4, 16. If the increase was like that, then it would have been an exponential function. All right. Is this clear to everybody? If there are no questions, then I'll move ahead. Okay. Fourth question. If f of x is given as max of 2x plus 1 and 3 minus 4x, where x is any real number, then the minimum possible value of fx is, so what's given here is f of x is given as max of 2x plus 1 uh, and 3 minus 4x. This is what is given. All right. Correct. Sanchita, you're correct. Derivative of a quadratic equation would be a linear equation. And derivative actually shows the variation. Variation in change in y with respect to change in x. So that change is linear. That change is linear. And the derivative of a quadratic equation is a linear equation. So that's why it's a linear. While in case of exponential, the derivative is also exponential. So the increase or the variation would also be exponential. All right. So this is how you can actually find out maximum of 2x plus 1 and 3 minus 4x. So this is what it's a max function. So what we do here is we draw a graph and we select the maximum value of these two graphs. So first is f of x is 2x plus 1. This is the first part and this is the second part. So we'll draw the graphs of both of them and then check. Uh, we'll select the maximum value, whichever of this is maximum. So we'll draw the x and y axis. Okay, this is x axis. Now what's given here is max of 2x plus 1. That means if this is fx. All right. So for x equal to 0, y would be equal to f of x would be equal to 1. And for x equal to minus half, uh, yeah, uh, f of x would be 0. So this would be minus half. So this would be the line of 2x plus 1. This is the line. Okay. Now 3 minus 4x. For x equal to 0, y is equal to 3. This is the second part. X equal to 0, y is equal, f of x is equal to 3. And for x equal to 3 by 4, x equal to 3 by 4, f of x would be equal to 0. So the line would be something like this. This would be the graph for, okay, this would be the graph for 3 minus 4x. Okay, all right. So yeah, now what we have to do is we have to this max function. This is a max function. So max function is basically whichever of the two value functions is max. This would be the graph. So this is the graph for the first line. This is the graph for the second line. All right. All right. Now the max function would be for till this point, the intersection point. This is maximum because this is lower. This part is lower. So this is the maximum. So we'll select this, and then up till after intersection point, 2x plus 1 line would be the maximum. So the graph would be something like this of max function. Yeah. This would be the graph. So the minimum possible value of fx would be this point of intersection. Minimum possible value of this fx function is basically the point of intersection between 2x plus 1 and 3 minus 4x. So minimum possible value would be 2x when 2x plus 1 is basically equal to 3 minus 4x, because that would be the intersection point. Before intersection point, 3 minus 4x is maximum. After intersection point, 2x plus 1 is maximum. Alright, so the minimum point is intersection point. So we'll find out the intersection point. 6x will be equal to 2. So x comes out to be equal to 2 by 3. So for x equal to 2 by 3, we will get the minimum value of fx. So minimum value would be 2 into 2 by 3 plus 1, which comes out to be equal to 4 by, sorry, 1 by 3. 1 by 3, 1 by 3. So 2 into 1 by 3 plus 1, which is 2 by 3 plus 1, which is 5 by. The minimum possible value is f of fx will be equal to 5 by. Alright. You can check for x equal to 2 by 3 in both. The value comes out to be same. 3x, 3 minus 4x. 3 minus 4 into 1 by 3. This also comes out to be equal to 5 by. Alright. Yeah. So that's why it's a point of intersection. This and this will be the minimum point, and the value is coming out to be equal to 5 by. Okay. Is this clear? Thank you so much, Sanchita, for correcting me here. Okay. Uh, okay. So if there are no questions, then we'll move ahead. If there are any questions, then please feel free to ask me in the chat. All right. So I'll move ahead if this is clear. So I think the best way to solve these kind of questions is to draw a graph. With the graph, you will be clear on what trajectory the graph is taking. And then from that graph, you will find what would be the minimum point. All right. So in this case, the minimum point is the point of intersection where the two lines are meeting. So just equate them, find out the value of x, that comes out to be equal to 1 by 3, and then solve for fx, that comes out to be equal to 5 by. Okay. So I'll move ahead. Okay. A function fx is defined for all real values of x as 2f of x plus f of 1 minus x is equal to x squared. What is the value of f of 5? Okay. So a function is defined by this relation, and we have to find out the value of f of 5. Okay. So let's first substitute the value of 5, x as 5. Let x be equal to 5. Then 2 times f of 5 plus f of 1 minus 5, which is minus 4. That would be equal to x square, which is 5 square. Do next is let x is equal to minus 4. Okay, let x is equal to minus 4. So then 2 of f of minus 4 plus f of 5 would be equal to, right? 1 minus minus 4 would be f of 5. 1 minus minus 4 would be f of 5. That would be equal to minus 4 square. This is equal to 25. This is equal to 16. So now what we are getting is we are getting two equations, this equation and this equation. And there are two variables whose value we don't know. We don't know the value of f of 5. We don't know the value of f of minus 4. Here also it is minus f of minus 4 and f of 5. So we have got two equations. We've got two variables. So let f of 5 be equal to a and is equal to 16. So just have to solve for a. We have to find out the value of a for a. So you can solve using elimination approach or any approach. So just multiply this with 2 and this with 1 and then subtract. So we'll get 4a plus 2b is equal to 50 and 2b plus a is equal to 16. So just subtract 2b and 2b would get cancelled. You would be left with 3a is equal to 50 minus 15, which is 34. So this gives a as 34 by 3, which is f of 5 is equal to 34 by 3. Alright. So f of 5 comes out to be equal to 34 by 3. Okay. So this looks a bit difficult, but when you solve it, you will find that here on one side we are given x, and here on another side we are giving 1 minus x. So the best thing would be to just swap the values of x. We need to find out the value of f5. So just first substitute the value of x as 5. We get f of minus 4. The next thing would be to just substitute x as minus 4. So you get two equations, two variables, solve for those two variables. You will get the value of f of 5 as 34 by 3, which is option C. Okay, not a very difficult question. Looks a bit complicated, but it's not actually once you start solving it. Okay, any questions on this one? I hope it should be clear to you. Any doubts? Any questions? No questions? Okay, then we move ahead if there are no questions. Okay, what's given here is f of 0 comma y is given as y plus 1. F of x plus 1 comma y is given as f of x into f of x comma y. Then what is the value of f of 1 comma 2? Okay. So what's given here is, it looks a bit complicated. F of 0 comma y is given as y plus 1. When x is 0, f of x 0 comma y is given as y plus 1. So basically f is a function of both x and y as variables, input variables. So when x is put as 0 and y is put as y, the function becomes y plus 1. When x is put as x plus 1 and y is put as y, the function becomes f of x and f of x comma y. So what we'll do first is, what we'll do here is, we'll put x is equal to 0 and y is equal to y. Alright, in this case, what we'll do is, we'll first put x is equal to 0 and y is equal to 1. So what we'll get here is, f of 0 plus 1 comma y would be equal to f of 0 comma f of x comma y, which is f of 0 comma y. Here is, we know that f of 0 comma y, if there was any interruption, guys, I'm really sorry. So what we did was, we put x is equal to 0 and y is equal to 1 in the equation, in this equation. So we LHS becomes f of 0 plus 1 comma y, and RHS becomes 0 comma f of 0 comma f of 0 comma y. All right. So LHS becomes 0 plus 1, which is f of 1 comma y. RHS becomes f of 0 comma f of 0 comma y. Now 0 comma f of 0 comma y is basically y plus 1. So this becomes y plus 1. 0 comma y plus 1. Now we know that f of 0 comma y is basically y plus 1. So then f of 0 comma y plus 1 would be just substituting y as y plus 1. Y is y plus 1, which is y plus 1 plus 1. So f of 0 comma y plus 1 would be equal to y plus 2. y plus 2. So we will just substitute this here. F of 0 comma y plus 1 would be f of 1 comma y would be just equal to y plus 2. Just this we found out as this. So now we have to find out the value of f of 1 comma 2. So just substitute y is equal to 2. So f of 1 comma 2 would be equal to just 2 plus 2 is equal to. So that is option. Okay. Looks a bit complicated. Approach step by step. We put x, so we know the value of 0 comma y, all right, and that is given as y plus 1, and we also know this relation. We have to find out the value of 1 comma 2. So the, if we have x as 1, so then, and here x plus 1 is given, so for x plus 1 to be equal to 1, x has to be put as 0. So we substituted x is equal to 0 and y is equal to y, because first right now we don't know. So then what we did got was f of 1 comma y is equal to f of 0 comma y plus 1, because f of 0 comma y is y plus 1. Now we know that f of 0 comma y is y plus 1. So 0 comma y plus 1 would be just substituting y as y plus 1. That comes out to be equal to y plus 2. Alright. So yeah, that means f of 1 comma y comes out to be equal to y plus 2. Okay. Any doubts, anybody? Any doubts? Please feel free to ask. I can explain again. First step, x is 0, y is y. Go ahead. We get f of 1 comma y as f of 0 comma y plus 1. So f of 0 comma y plus 1 we find out as y plus 2. So f of 1 comma y comes out to be equal to y plus 2. So yeah, the final answer becomes 2 plus 2 equal to 4. All right. So I'll move ahead then. Yeah. The next question, f of x is given as x cube minus 4x plus p. Okay. And f of 0 and f of 1 are of opposite signs. Then which of the following is necessarily true? Okay, so what's given here is there is a function f of x as x cube minus 4x plus p, and f of 0 and f of 1 are of opposite sign. So let's substitute. For x, f of 0 would be 0 cube minus 4 into 0 plus p, which is p, and f of 1 comes out to be 1 cube minus 4 plus p, right? Is also negative, right? If p is negative, then p minus 3 would also be negative. So then that these are of same signs. So p cannot be less than 0, right? P cannot be negative. So this option is wrong, right? We eliminated this option. The next option is basically p has to be positive. So if p is positive, then p minus 3. If p is positive, if p is positive, then p minus 3 has to be negative. f of 0 as p and t minus 3. If p is negative, then p minus 3 has to be negative. There's no other way. That's true. I'm sorry for the interruption once again. If p is negative, then p minus 3 has to be negative. So p has to be greater than 0. There's no positive, right? So the next option that we have left is if p is positive, then p minus 3 has to be negative because the signs are opposite. Okay. So if p is positive and p minus 3 is less than 0, then that means p has to be less than 2. So we get the value of the range of p as between 0 to 3. All right. Yeah. Okay. So we are done. I don't have any other questions. We discussed 7 questions in detail, I think. If there are any questions, then please feel free to ask. Or if there are any queries, please feel free to express those. I'm happy to answer. So every year in CAD exam, we get at least two questions from functions. At least two questions. 2 to 3 questions maximum. 3 questions maximum you'll get, and 2 questions minimum you'll get. And you, from the questions that we discussed today, would get an idea that these questions are not very difficult. They may look a bit complicated, especially the composite functions, but once you start solving them, they are not very time consuming. All you need is basically just that one click on what to substitute, where to substitute, that's it. And most of the time, you can get the answer from the options by eliminating them. All right. So yeah, no questions, no further explanations required from my end. If there are any doubts, then a division in function is possible. Uh, what do you mean by division, Shiva? You mean f of x divided by f of y? That's what you mean? Yeah. If that's what you are talking about, then that's also there. You Yeah. Basically, you can be given a question like f of x like that. These kind of questions you can be given. Like you were given f of x into x, f of y is basically f of xy. So these kind of questions you can be given. So many a times this should come like you can assume certain functions like the yeah like f of x into f of x y is basically f of x y. Then basically it's just a square function. All right. So yeah, using those kind of tricks would make your work a bit easier. Would make you take less time. So yeah, most of the time the questions are simple, not very much, not very difficult, and yeah, you can substitute the options, you can eliminate the options, any values of x and y to eliminate those options, and anything you can do any sort of stuff and shortlist your right answer. Okay. If there are no further questions, then thank you so much, guys, for joining. Have a happy Sunday ahead and stay safe and practice as much as you can because the deadlines are approaching. So, all the very best and yeah, uh, happy dinner and a happy Sunday. Okay. Thank you so much, guys.